Express 3 sine theta minus 4 cos theta in the form r sine theta minus alpha. So let me expand this using the addition formula to be r sine theta cos alpha minus r cos theta sine alpha. And now let me write the 3 sine theta minus 4 cos theta underneath. Comparing the two, I can see that I've got the r cos alpha is going to have to equal 3, and r sine alpha is going to have to equal 4. Just rearranging a little bit will allow me to draw a little right angle triangle where the hypotenuse is r. And if this is alpha here, the opposite side of this triangle is going to be 4, and the adjacent side is going to be 3. So a little bit of Pythagoras to get r. And tan alpha I know is 4 over 3. So tan inverse of 4 over 3 is 53.13 to 2 decimal places in degrees. So that's part A of this question done. Let me just write that down then. That the 3 sine theta minus 4 cos theta is the same as 5 sine theta minus 53.13. Okay, we're then told that the temperature in a greenhouse, G degrees Celsius, is modelled by this equation. Now comparing that to what we just did, we've got the 17, which is new, but then we've got the 3 sine 15t minus 4 cos 15t, which is exactly the same as what I did in part A. The only difference is we've got 15t instead of the theta. So that's allowing me to use my answer from part A to rewrite the model like that. Find, according to this model, the maximum temperature of the greenhouse. So I just forgot the 5 there in front of the sign. Yes, so the maximum temperature of the greenhouse. Well, I know that the biggest that sine can possibly be is 1. So the maximum temperature of the greenhouse then will be 17 plus the 5 times by the 1. So we get 22 degrees Celsius. Then for part II, we want to find the time after midday when the temperature in the greenhouse is 20 degrees Celsius. So when G is 20. So we'll subtract the 17 from both sides. We'll divide both sides by 5. Then I'll do sine inverse of 3/5. So sine inverse of 3/5, and we get 36.869 But I know that's not the only answer. There could be other answers. We know that from the sine graph there could be another answer. So we've got 3/5 here. A couple of possible answers here. We've got the principal answer of 36.869 there. We could have another answer that's 180 minus that, which would be 143.130. And there could also be other solutions over here as well that I could possibly need. 360 plus that, or 540 minus that. We could need those other ones, possibly. Right, we're then going to add the 53.13 to both of these. And then divide by 15. Now that 5.999 hours after 11 AM, well, that will take me to just before 11 o'clock, which, considering we want the time after midday, we don't want that answer. Let's go to the second solution. So we've got the 143.130 plus the 53.13 divided by 15 gives us 13.084 hours after 5 AM. So when I add that to 5 AM, I get 18.084 hours. We need to give our answer to the nearest minute. So let's turn the 0.84 into minutes by timesing it by 60. And we get 5 minutes. So it's 18 hours and 5 minutes, or 18:05, or 6:05 PM if you prefer. That is the time after midday when the temperature in the greenhouse will be 20 degrees.